actual responses from a student survey I gave in the past. I asked 27 students, how many siblings do you have? This is a list of the 27 data points that we got. In part 2 on this classwork, I'd asked you to determine, with 27 data points, the largest being 11, the smallest being 0, what should the class width be, and set the class boundaries. We found the class width was 2, and we found class boundaries were 0, 2, 4, 6, 8, 10, 12. All I've done is rearrange that data slightly, set up what the class boundaries were, to where we can now figure out how many things fit into each class. The question, how many things, is really a question of what's the frequency of that class. So when I look for 0 to 1, I'm going to put a check mark above everything that counts. 1, 2, 3, 4, 5. So 0 to 1 has a frequency of 5. I'm going to put an X above everything that's a 2 or a 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14, we're between 2 and 3 siblings. For 4 to 5 siblings, I'm going to put a star. 1, 2, 3, 4, 5, 6, 7. So the frequency there is 7. For 6 to 7, I'm going to put a box. 1. That's the only one. For 8 to 9, I'm going to put a circle. That's the only one, 8 to 9. So again, the frequency is 1. And we're left only with things that are 10 or 11, specifically this 11 and this 10. That's why the frequency there is 2. So basically, I count how many of the data points belong to each class. Once I've determined those frequencies, I'm going to put it into my frequency table. So I'm going to list those frequencies: 5, 14, 7, 1, 1, 2. Once you have the classes and the frequencies, getting the next 3 columns is all about just following formulas. The formula for class midpoint is I take lower class limit plus upper class limit and divide by 2. So 0 plus 1 divided by 2 gives me 1/2, or 0.5 as the first class midpoint. If I do it for the second class, 2 plus 3 divided by 2 gives me 5/2, or 2.5. What's normally going to happen every time is if you just add your class width to the first midpoint, that's going to be the midpoint of each of the next ones. So the first midpoint was 0.5, the class width was 2, 0.5 plus 2 got me to 2.5. Adding another 2 gets me to 4.5, 6.5, 8.5. There's times where you have to be tricky with this last row, because really this last row could be slightly larger in width if we're trying to do something where we rounded what our class width was and we need to make the last category a little bit larger. It's going to possibly change what this midpoint is. In this case, we didn't really have to do this. The midpoint continues to be what we'd expect it to be, just the class width away from what came above. So really, I'd want to check this one and do 10 plus 11 divided by 2. That'd give me 21 over 2, which is 10.5. So it does still follow the pattern, but really you always want to check the last class. Our formula for relative frequency is we need to take the total number of data points, take the frequency in that class, and divide it by that total number of data points. We were told that there were 27 students. That said, you always just like to check at this point. 5 plus 14 is 19, plus 7 is 26. 27, 28, 29, 30. Something went wrong here. Let's go back and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So what went wrong is I labeled this wrong in this classwork. This really should say 30 students. Apologies. That is part of why you want to add up this frequency column to make sure that you know what you were out of. So since I'm actually out of 30 students, this first class relative frequency would be 5 divided by 30. That's really 1/6 or 0.18. So if I put it into my calculator, 5 divided by 30, 0.17. If I now do 14 divided by 30, my calculator tells me that 14 over 30 is 0.47. If I do 7 divided by 30, I get 0.23. If I do 1 divided by 30, I get 0.03. This is the same 1 divided by 30, which gives me 0.03. And then finally, 2 divided by 30 gives me 0.07. So these are the relative frequencies: 0.17, 0.47, 0.23, 0.03, 0.03, and 0.07. Cumulative frequency really just asks me to take the total of that row and all rows above it. So for this first row, we have 5 as the frequency. There's no rows above it. That means the cumulative is 5. For the second row, we have 14 here plus 5 above it. 14 plus 5 gives me 19. For the third row, we have 7 plus 14 is 21 plus 5 is 26. You can do it that way and just look at frequencies and add everything above. Or what I find is easier is taking the previous cumulative and adding the new row. 19 plus 7 gives me 26. Plus 1 gives me 27, plus 1 gives me 28, and finally plus 2 gives me my cumulative of 30. It should always be the case that your final row's cumulative frequency equals the total number of people in the study. If I'm now asked to create a relative frequency histogram, what that's really asking me to do is to look at this column of classes and this column of relative frequencies. So I'm going to start by making my axes. I see that the relative frequencies are all between 0 and 0.47, so I'm going to go by 0.1 up to 0.5, 0.1, 0.2, 0.3, 0.4, 0.5. I want to make sure it's labeled relative frequency. Here, my first class is 0 to 1, then 2 to 3, 4 to 5, 6 to 7, 8 to 9, 10 to 11. And I'm going to label that number of siblings. When I look at my first bar, 0.17, from 0 to 1, I'm going to go a little bit below the 0.2 and draw down my bar. Notice that the bar connects to the axis, unlike what happened with a bar graph. When we're making histograms, either just a frequency histogram or a relative frequency histogram, we want to make sure the bar touches the axis and each subsequent bar touches the next one. So we're then going to 0.47, which is way up here. Let's say about like that. After 0.47, we're at 0.23, maybe about there. After that, we're at 0.03. Down here, 0.03 again, and then 0.06, which is about twice as tall. This would be a proper relative frequency histogram. Again, what I care most about is things like labels, relative frequency, number of siblings. First bar touches the axis, each subsequent bar touches each other.